All right, welcome everyone to our second session of the Adaptation Planning and Practices course. Today we will really deep dive into understanding and evaluating how climate change will affect our sites. Just as a reminder, if you can make sure that you are muted throughout this lecture, that would be super helpful. This is recorded and will be available to you after the session as well. Great. Well, welcome back. Today I want to introduce a new person for you to meet. This is our colleague Leslie Brandt. She'll be joining me today in this lecture. Leslie, would you like to introduce yourself?
Hi everyone, I'm Leslie Brandt. I am one of your co-instructors and I am focused on the central hardwoods region as well as urban forests, and I'll be helping with the lecture today talking about vulnerability and adaptive capacity. I am based in St. Paul, Minnesota, so unlike many of the other NIAX folks, I am in a big city, and I am joining from home today. My daughter is sick, so hopefully that won't affect our lecture at all today. But just warning you, if things go south, I might have to duck out.
Well, thanks, Leslie. We appreciate you being here, and we love it when you rub it in that you live in a huge metropolitan area, because we live in a rural, very rural area. Anyways, we're happy to have Leslie here today. Today's agenda is first, to meet your class. I'll do a short summary of just your project locations, where you're at, but we'll save the bulk of that discussion for the discussion session, which we have after this class and tomorrow. Next, we'll start digging into the key concepts and ideas of what we're going to be doing today in lecture or in step 2, just covering those big ideas while also sharing some additional resources that might be helpful to you this week. And lastly, we'll go over our assignment and homework for the next week. Just as a note, this will probably be our last long lecture, so this one will probably take more than 30 minutes, but the next several weeks will definitely just take 30 minutes. Okay, so if you are wondering where all of your course participants and fellow colleagues are located, the projects that people brought are really from all over the Midwest and the Northeast. You can see folks from Minnesota to Maine to Missouri and Maryland. We are everywhere. And actually outside of the Midwest and Northeast in the District of Columbia in Washington, D.C. So we are so excited to have all of you folks here and are really excited to learn more about your projects as the weeks go on. Okay, so last week we began the adaptation workbook and looked at defining our area of interest and really getting down to brass tacks as far as carving out clear and definable goals and objectives. And this is something we'll return to in the discussion section to take a peek at what you came up with, and also to facilitate some more coaching if you guys need that help as well. This week, we'll be jumping right into step 2, which is all about assessing climate change impacts and vulnerabilities for your specific project area. And this is where we start bringing in additional resources that can help
Hey, Danielle, some folks are having trouble hearing you.
Oh, okay. Let me take a look at what's going on with my audio. I'm not sure. Leslie, can you hear me?
I can hear you just fine.
Okay, I am unsure. It might be your computer. Okay, I'm not sure what's going on for some folks, but for others, maybe just, turn your computer off, turn it back on, and we'll have the recording and we can live through this moment again. Okay.
Yeah, I mean, the volume might be a little different between mine and Danielle, so you might just have to adjust your volume a bit on your computer.
Yeah, I looked and everything seems to be in check, but I guess keep checking in if it's difficult for you to hear me. I'm sorry about that. I'll just talk really loud. Okay, so let's get to it. Let's learn a little bit more about step 2. Okay, so we know that climate change will have a huge, wide variety of effects on the landscape, but not all places will respond similarly, right? So for that reason, we need to start thinking about how those statewide or regional climate impacts will affect the ecosystems that we care about in that specific project location that you brought to this course. In the end, some forests may have greater resilience than others. So it's really helpful in this step to start carving out how your site and the forests that are on your site might be more or less susceptible to climate change. And you do this using your own judgment, your own expertise and experience related to that site. So, what we're going to do in essence is really described in this screen. We're going to evaluate those big climate change projections and then combine them with our local expertise to really get down to, those relevant characteristics that can change the vulnerability of our forested ecosystems. The big questions that we'll be asking ourselves is really simply, how might the area be uniquely affected by climate change and the subsequent impacts of climate change? And how might regional climate impacts be different in the project area? So again, in this step, you'll take and consider broad scale scientific information, and this information we're going to talk about in a little bit, but it is preloaded into the adaptation workbook, and it comes from ecosystem vulnerability assessments and other published resources. Again, we'll talk about that in a little bit. After you identify the relative general climate impacts that you think are a priority for your site, you'll use your expertise and judgment to evaluate how that property might be more vulnerable to climate change, because there is a great deal of variability among different locations. So your understanding of specific site conditions in that location will help you to identify the more relevant management responses in later steps. So it's about thinking about the big broad statements that we'll give you in the adaptation workbook, but then taking time to really think about how your area might be more or less vulnerable. What is it about your area? What are those key considerations? So as you consider those broad impacts, we'll ask you again to step that down. So if you have an upland forest and there's some regional vulnerability assessment information that we're giving to you, describing changes in precipitation patterns where maybe more extreme precipitation events is predicted for your area, you might think about your project location and say, hey, there are actually some inherent characteristics about my site that could change the vulnerability of that site and make it more susceptible than others. Maybe the slope and soil on this property may increase flooding and ponding, whereas that might not be an issue on the other side of the site. So you can sort of see how we're helping you link, your site, draw out those characteristics of your site and connect them to the big climate trends that are out there. And again, we'll talk about this in more detail throughout this lecture. So before beginning step 2, we're going to ask that you learn a little bit more about the regional climate change projections and the projected vulnerabilities to forests in your region. The adaptation workbook does come preloaded with several statements, but you're probably going to get more out of this step by really digging into all of many available resources that are out there for you. We've included a ton of links in the Getting Started guide to different videos. Each video is less than 30 minutes long. So, find your region, watch the video, get a sense of what those big climate trends are, and get a sense of how forests might be affected before you dig into your own project as well. You'll find that if you bring other information as well, location specific information, that might also help you make these connections as well. So anything that's related to your project location that could help to better describe the key characteristics of your site, from tree species lists and inventories, soil maps and flood maps, maybe a map of the facilities and the roads, culverts, and maybe even an elevation map, so you have a sense of where are those high and those low spots on the landscape. And again, we'll ask that you review any of the information that's related to this step in the Getting Started guide before you get started in the adaptation workbook. It'll probably save you a few headaches as well. And I'll hand it over to Leslie to review some climate change resources that may also help with step 2.
All right, let's see, how do I take over remote control here? Do you need to do that for me? Right. Let's see if this works.
Okay, remote controlled. What's going on?
I don't know.
It says you're controlling.
I'm using the arrows.
I'll just next screen it. There you go.
Okay, thanks. So in addition to the information that we have provided directly in the workbook, there is more detailed information provided in a number of vulnerability assessments that we have developed for different regions or subregions within our larger region. These are written for forest managers. They include climate trends and projections. It's focusing on forest ecosystems. There's one that's focused on urban forests for the Chicago region, but you will find information relevant to urban forests in pretty much all of these resources. It looks specifically at the vulnerability of tree species using models, as well as natural communities and forest types that are common in each of these subregions. And it doesn't tell you what to do, but provides you with a range of potential futures in order to better understand your impacts to your area. Next slide. In addition to those larger vulnerability assessments, we also have tree species handouts that are specific to different regions. These are often more specific than the larger vulnerability assessments. So these are for ecological sections. And there's some more areas beyond just the ones that we've used in the vulnerability assessment. So for example, there's one for the driftless area in Western Wisconsin, southeastern Minnesota that doesn't have a vulnerability assessment. And these include projections of which species are expected to increase and decline, as well as additional considerations when selecting those species. All right. A lot of this information is from the Climate Change Tree Atlas, which is a great resource if you haven't checked it out yet. You can find it on the link below, and I believe that it is also in your Getting Started guide. It provides projected changes in suitable habitat for 134 tree species, and there's also projections for suitable habitat for 147 bird species across the eastern United States. These projections are provided around a range of emission scenarios, or sometimes you'll see it listed as emission scenarios of B1 or A1FI, and sometimes you'll see RCP 4.5 or RCP 8.5. And RCP stands for Representative Concentration Pathway. And this is just a projection of how much carbon dioxide is expected to increase in the atmosphere. And so the 4.5 is lower emissions, and the 8.5 is higher emissions. And so the B1 and 4.5 are similar, and the A1FI and 8.5 are similar. And so that gives you a broad range of future conditions. We also have projections under a couple of different climate models. The PCM model is one you will see in a lot of our reports, and that is a model that projects a wetter climate in general for the Midwest and Northeast and less warming than some other models. And the GFDL and Hadley models you will also see in a number of our assessments are more sensitive to increases in greenhouse gases. So they project higher warming, and they tend to project higher, more drought and less precipitation during the summer. So how do you use the tree atlas information? First, it's important to know that this projects changes in habitat suitability, not migration. So it is not projecting movement of trees. It's just saying where a tree could potentially grow. It's at a pretty coarse spatial scale, so you can't narrow in on a particular site and say, oh, because this dot says that the species should grow here, that means I should plant it. So it's good for getting a general regional picture and a general sense of how habitat suitability might change. It doesn't account for things like the urban heat island or lake effect, but it does include things like soil type and precipitation and topography. So it's more than just looking at changes in temperature. So it is a really useful tool. It's a tool and it's a model. And so it's not going to be right everywhere, but it gives you a sense of the general projections for your area. So an example of what these look like, this is a projection for Honeylocust. On the left, you see its current range. So all those areas in dark green and blue are the most suitable habitat for Honeylocust based on forest inventory and analysis data. Then on the right, we see projected changes in habitat at the end of the century under a low emissions on the top and a high emissions scenario on the bottom. So the high emission scenario is, and the low emission scenario are both projecting a shift of suitable habitat from areas in southern Illinois and Missouri and eastern Kansas up into places like Iowa and Minnesota and Wisconsin. If you want to get more specific to your particular area, we have a new set of information, and you cannot access this link directly through the general link to the tree atlas data. So you have to use this link below, and we'll make sure everybody gets this link. And this gives you a summary of projected changes for 1 by 1 degree latitude and longitude areas across the eastern United States. So if you don't know where your location falls in that grid, just you can look up your latitude and longitude and then see where it falls on that grid. And there, you can blow up that map to look at that if you need it. And so once you click on this link, it will give you a link to Excel files and PDFs for each 1 by 1 degree latitude and longitude area within the eastern United States.
Yeah, and Leslie, really quick, I'm just going to interrupt. This will be a really handy tool for folks in DC. So if you're in Washington, DC, this is probably going to be one of the tools that you'll want to use. So just reach out to Leslie or I, and we can help facilitate getting you this information and walking you through how to use it.
Yeah, and any of the rest of you who have a project area that might fall outside of our vulnerability assessment footprint areas, this can be really useful. All right. So what you will see if you open up these files are these, it looks a little complicated, and it's not, I guess, the most aesthetically pleasing. It's done by scientists, so bear with us. You will find a list of species by common and scientific name. Then there is a bunch of other information. The definitions are all in a tab that says definitions short. And so if you go there, it'll have all those headings listed. The thing you'll want to pay most attention to, though, are the change CL 45, which is the projected change under that RCP 4.5 scenario, and then the change CL 85, which is projected change under the RCP 8.5 scenario. And so, for example, this example is showing that under both scenarios, you're for this particular area, and I think this is in Florida, pond cypress is showing no change under both scenarios. Persimmon is seeing a large decrease under both scenarios, and laurel oak is seeing an increase under both scenarios. Now, sometimes you might see a difference between those two scenarios, and usually that's driven by precipitation differences. So for example, slash pine under a high emission scenario where you have a decrease in precipitation is seeing a decrease in suitable habitat, whereas under that low emission scenario, you're seeing an increase in suitable habitat.
Yes, and just also jump in, although these Excel files are horrible to look at, they contain a lot of really great information. So as Leslie pointed out in that bottom screenshot, there's a ton of helpful text that's written for the layperson to understand what each of these columns mean. And I think that if you were to download these Excel spreadsheets, you would learn an awful lot and would find these other columns also probably pretty helpful in informing your decisions.
Yeah, so for example, the FIA sum and importance value gives you a general idea of how common that species is in your 1-by-1 area. And then what they've done in that abundance column is translated that into a categorical value. So if it's really common, then you can see that it's listed that way in the abundance column. The adapt column is also really useful. So that gives you an idea of the adaptive capacity of the species, and we'll talk about that in a little bit. There's also some information about how likely that species would inhabit the area and move into that area on its own based on its dispersal. So that's under these shift columns. So if you're looking to see, okay, which species are really likely to migrate into a particular area, you can look in those columns.
Yep, and we'll get that link and put it into the email, into the chat box, and maybe Leslie, you can do that while I do the next slide.
All right.
Okay, so that was a really big deep dive into some of the forest ecosystem information that is available to you. Again, Leslie mentioned early on, you know, the information that's within the adaptation workbook online is preloaded. A lot of it, if you're in the Midwest and the Northeast, is preloaded from those assessments. So we took a summarized version and tossed it into the adaptation workbook so that you could then integrate that information into your planning pretty quickly. So what I'm showing here is if you are curious what climate impacts are provided to you based on your location, you can take a peek without actually going through step 2. And you can do that on the home page of the adaptation workbook. You go up to Explore and you click a link for Explore Impacts. Here you'll find this really awesome map. It's actually very interactive, and you can click on the blue or the green, and a pop-up screen will show you the summarized climate projections for your area. These summarized climate projections, these impacts are actually, like I said, if you were in the green area, are drawn from our vulnerability assessment areas. If you're in the blue areas, they are summarized across the entire blue area. So it'll be an impact that's for the entire blue area, and that is drawn from the National Climate Assessment. We're working on updating these climate impacts for the blue areas so that they reflect the most recent National Climate Assessment, but they actually reflect the 2014 assessment. The trends are pretty much the same. So this is what you will see when you are in step 2. You will see climate impacts, and then you'll also be able to navigate around to better understand, you know, a short description of that impact, and then you can find a link. But if you want to quickly access this information, maybe for some grants, if you're looking to, summarize what the climate impacts are for your region, just pop over to the adaptation workbook and use that Explore Impacts tool. It's already been a really handy tool for us when we're doing like grant applications, for the Wildlife Conservation Society or something, and trying to build the case for why our area will be vulnerable to climate change. So definitely check that out. All right, but there's even more resources you could use. And, we have, again, preloaded our vulnerability assessments, but we've also linked to several other resources and then digested them in our resource finder, which you can navigate when you go to the adaptation workbook, and you can click on resource finder before you're inside your workbook plan. And there you'll find a huge browsable list of resources. So let's just sort of jump through a few of these. We definitely don't want you to limit yourself to just our vulnerability assessments. That's not what we're trying to do. We're just trying to make it a little bit easier for you to get started by providing that information. We want you to take in as many other resources as you can without overwhelming yourself. One thing that we have used in the past and we have found to be super handy are these state summaries that are provided by NOAA. The state summaries give a really clear understanding of observed past change, and then pair it with national climate assessment information that gives you an understanding of the projected change for your state. These are incredibly awesome. They're 2 to 4 pages long. But unfortunately, I think they're being updated right now. So we are having a hard time finding them. If you can find them, cherish them, love them, and send us a link. I think that they're being updated, but they're really handy, and I have a few printed out for the states that I'm commonly working in. Other information, you may have came to this course with a clear understanding of how climate change will affect your resource area because you were an author or you know of a cool report that's based on the topic that you care about or the place. And we want you to bring that information in. So there is and we'll go through how to use the workbook in the discussion group, but there is an opportunity for you to add your own vulnerability information. And several of our past course participants have done that in their adaptation planning. So all you have to do is add the statement, copy paste from the report, and then provide a link or a citation to the report in the adaptation workbook so that it will be included in your final plan. It's pretty easy. Other tools, there are some really cool tools that are coming out there. One tool that we like to point out is a regional tool for the Midwest and the Northeast, and it really helps to shape our understanding of how changes in hydrology might affect aquatic habitat throughout this area. And this is a really cool tool that was developed from the USGS. It's called FishViz, and it gives us a really interesting outlook into how fish distribution and community composition might change based on changes in temperature that could alter the thermal or hydrologic characteristics of the surface water. So you could use this tool that could help inform some of your ideas of how your area might be vulnerable, but there are tons of other tools as well. This is just one really neat tool that we like to point out. And now I'll hand it over to Leslie to talk a little bit more about those big unknowns. What do you do if you are not in our tool?
All right. Still trying to see if I can advance this by myself. It seems to sometimes work.
Okay, I'll do it.
All right. Okay. So in addition to the tree atlas, we also have projected changes in hardiness zones and heat zones for the entire conterminous United States. This is featured in a story map, and the link to that is below. And that will show you the historical hardiness zones and heat zones, as well as projections for the end of the century. Now, if you want to dig in even deeper, let's see. Can you go to the next slide? You can access there's a link on the story map, or you can go to this link directly. You can go to this ArcGIS online set of maps that shows projections under both that low emission and high emission scenario for 30-year periods. And so if you're really interested in looking at a particular time period or a particular location, you can even download these maps into your own ArcMap by going to that information tab and then clicking on more details, and then you can open in your ArcGIS desktop. You can also just use it directly in the viewer tool and zoom in on your particular state. So there's lots of functionality here if you want to dig deeper on understanding how changes in hardiness zones and heat zones might shift.
And Leslie, why would this be important for some people?
Well, I think most people who make decisions about planting lists for their particular location are making those decisions based on what can grow there based on hardiness zones. So horticulturalists and gardeners use this all the time, but a lot of arborists are using this as well. So if you're working in an urban area, this can be really useful for understanding which trees in your area might no longer be able to withstand high temperatures or might not have the cool periods during the winter that they need.
Yeah, and lastly, just to jump in, I'm finding that a lot of plants are not commonly modeled, and this is a particular emphasis in the wetland community. So using a tool like this, taking the information that we already have on plant traits and characteristics, but then it gives us an opportunity to cast a net forward. How might those plants, find better habitat in the future?
And so what we're seeing across most of the United States is a shift of like 1 or 2 hardiness zones, and usually a bigger shift in heat zones, especially under that that high emission scenario. So summer temperatures getting a lot hotter, and heat zones are determined by the number of days above 86 degrees Fahrenheit, and hardiness zones are determined by the average coldest temperature over a 30-year period. So that gives you kind of the warm extreme and the cold extreme tolerance for those different trees. And so if you need help navigating through this, I'm happy to help you. So I'll just walk you through an example of how I've used this information, and you might use it differently. So this is an example with Black Hills spruce. So if you look up the published heat and hardiness zone ranges on the web or in a book, you'll see that the hardiness zone range for that species is between 2 and 8, and the heat zone range is 1 to 7. And then if you look up the current and projected zones over that species lifespan, like assume that it's living for 80 years. The hardiness zone range for this particular location that I selected would be 6 to 8 between now and the end of the century. And then the heat zone range is it would be 4 now, and it could go up to 8 by the end of the century. So then if you compare the species tolerances to the projections, the hardiness zone range is within the projected range, so it should be fine from that perspective. But the projected heat zone might exceed that species tolerance. So for example, that species cannot tolerate a heat zone above a zone 7, but if it gets up to zone 8, it might get too hot and it might stress that species. All right. Other resources for urban forests, like I mentioned before, we have an assessment for the Chicago wilderness region. And even if you don't work in the Chicago area, it can give you a good sense of what types of impacts to think about when you're thinking about urban forests. We also have tree vulnerability lists for a number of urban areas across our region. And we've also pulled together hardiness zone and heat zone maps and 4-page summaries for some locations as well. I think Am I turning it back over to you now, Danielle?
Good. So basically, through all of this, all of the resources and all of the introduction that Leslie and I have just provided to you, we just want to give you a quick reminder that step 2 is all about articulating what climate change impacts, what ones will affect your project area. You might have to prioritize a smaller list. It might be hard to look at that list and say, well, they're all going to affect my area. But as you think about it, you might be able to, shorten that to a shorter list. So, but stick to impacts. Think about how those regional climate impacts will affect your project area. Try not to connect them to anything else but your areas, your area. In step 3, we will explore more on how to create, linkages between climate change and potential challenges and potential opportunities that will affect our management. So for now, we're just looking at the project area. Just wanted to clarify. Okay, so, oh, no, this is still you, Leslie, I think.
It is?
Yeah.
Okay. Okay, so once you start thinking about what the impacts are for your particular location, you're also going to think about the vulnerability of your location as a whole. So how vulnerable is your forest type or a particular location within your larger area to climate change? So what is vulnerability? We want to have a definition because these definitions can vary a lot across disciplines. So when we're talking about vulnerability, we're talking about the degree to which a system is susceptible and unable to cope with adverse effects of climate change, including climate variability and extremes. In other words, are climate change impacts going to cause substantial disruption to your system? You can also think about vulnerability this way, as consisting of 2 main components: the potential impacts of climate change and the adaptive capacity of your system to cope with those impacts. When we think about potential impacts, we want to consider what the system is exposed to. So what are the changes in temperature, rainfall, storms, dominant species, or stressors, and how sensitive the system is to those changes. So for some systems, they can be exposed to a lot of different changes and they're not very sensitive. Whereas other systems, for example, a peat bog in northern Minnesota, can be very sensitive to even a small change. So for example, 2 forests could both be exposed to 3 degrees of warming, but a forest with spruce trees may be more sensitive to the impact than a forest with oak trees. When you're thinking about adaptive capacity, this is how well the system can cope with those potential impacts. This can be also thought of, if you've heard the term resilience, you can think of adaptive capacity being relatively equivalent to the resilience of the system. How resilient is it, and assuming no management or intervention. So for example, a forest containing a variety of northern species may have a greater capacity to adapt to warming than a forest containing 1 northern species. So you might still have enough species in your mix that you're still able to retain the general ecosystem function, the general community composition, even if you lose 1 species. If you're looking at the adaptive capacity of a species in particular, this is where that adapt column comes in when we're talking about the tree atlas data. We use what we're calling modifying factors or adaptability scores, which are developed based on the tolerance of a species to different disturbances like pests and diseases or drought or flooding. And then biological factors, life history traits like shade tolerance, edaphic specificity. In urban environments, that can include things like ease of establishment and propagation, and in natural environments, that could include things like the ability of that species to disperse. So a species could have a high adaptive capacity if it's able to withstand a lot of disturbances and exist on a variety of sites, and a low adaptive capacity if it is susceptible to a number of disturbances and has very specific site condition requirements. We can also think about adaptive capacity as an ecosystem. So things that would enhance the adaptive capacity of a system as a whole include things like species diversity. It can also be things like connectivity. So how able is that our species able to move across the system? In forests, age class diversity can be a big component of adaptive capacity because very young trees and very old trees can be more susceptible to mortality. Then finally, thinking about genetic diversity. So for example, when we're thinking about emerald ash borer coming through, a lot of the ashes that were planted were all pretty much the same genotype. They didn't have a lot of capacity to adapt to that pest disturbance. Whereas when we're looking in natural systems, what we're finding is a number of particular individual green ash trees have been able to withstand emerald ash borer. So that genetic component, the genetic diversity component, can be really huge as well.
Yeah, and additionally, for those who are thinking about that interaction between not only trees in the landscape, but the hydrology and hydrologic change, there's a hydrologic adaptive capacity, you know, the ability of your watershed or your landscape to cope with these changes. And we can really start breaking this down into, you know, what is the hydrology of your system? Is it driven by precipitation or is it driven by infiltration and groundwater sources? That can be an indicator of, you know, that high or low adaptive capacity. Probably most importantly is, you know, what is the buffering capacity of your site? How would your site respond to changes in precipitation or, you know, changes in drought or longer duration flood events? What kind of soil, slope, topography does this site have, and does your site have the ability to store water for longer periods using wetlands, or, you know, is it connected to its floodplains? Another important consideration is taking a look at a map and saying, where are we in the watershed? Are we up in the headwaters or are we down in the outlet? And once you decide where you are in the watershed, then you can start thinking about the cumulative effects of changes in precipitation and changes in hydrology. How might your site be affected by sites upstream? You'd probably have less of an adaptive capacity if you're in the outlet than you are in the headwaters to cope with some of these extreme hydrologic changes. And lastly, thinking about your upstream neighbors. This is an incredibly important concept in urban areas. Who's upstream from me, and what are those possible pollutants? How might those pollutants jump out of their safety bins during an extreme event? You know, what do I need to prepare for in order to cope better with those changes that my upstream neighbors might force down on me? Other physical features that might enhance a watershed to cope with climate change, you know, relate to those big, broad ideas that we're already thinking about in watershed restoration, from connectivity of habitats, maintenance of that floodplain, and in wetland and other landscape features. So, you know, these are great ideas that can really help you, help to trigger the idea of where am I in the watershed and how might my watershed have a certain adaptive capacity. If you want to explore these ideas a little bit more, definitely find that forest hydrology link in the Getting Started guide. The lecture itself is about a half an hour, and although it is based and it uses Pennsylvania as the basis for a lot of the discussion, the key concepts are totally applicable across the entire Midwest and Northeast. Adding on to what Leslie laid out when we're talking about adaptive capacity, there are more factors to consider when thinking about your site and the future of its, the future vulnerability. And when that comes into urban areas, we're thinking about extreme complexity. Every site is linked, might be driven by different biological, organizational, and economic or social factors that will differ among communities. So just because a forest might not be vulnerable in one part of your region, it might be more susceptible and more vulnerable based on some of these other human factors within your own urban forest. Okay, so a lot of information we just shared with you, and all this information is included in the adaptation workbook, the print version and online. So we were just giving you, the long version. Now, after you've established the potential impact based on your expertise, and then you've really thought about the adaptive capacity of your site, you will arrive at vulnerability. Vulnerability is simply defined as the degree to which a system is susceptible to and unable to cope with adverse effects of climate change, including climate variability and extremes. The really neat part of the adaptation workbook is that we've given you the ability to determine, what collectively would the potential vulnerability of your ecosystem using these interactive sliders. So, recall that vulnerability takes into account both potential climate impacts as well as adaptive capacity. And so we'll ask that you evaluate what is the degree of disruption that these potential impacts might have on your ecosystem. And so you can move this little yellow dot anywhere you want on this scale. And then you'll move down and you'll really decide and determine how resilient your system might be based on the several factors that you've outlined related to adaptive capacity. And you can move that slider as well. And that slider will then we'll then put this little dot on a graph, and I'm not showing it here, but I've sort of shown you a screenshot, and it will give you a sense of what the vulnerability of that system is. You can move that dot based on your own ideas of what vulnerability might be for your site. And we've loosely binned these ideas into a high, moderate, or low vulnerability determination. High vulnerability being that you expect that that the climate impacts will exceed the ability of this ecosystem to cope with impacts, all the way to a low vulnerability, which is, you sort of feel like the ecosystem is able to cope with a wide variety of climate change impacts. So, again, you decide, you choose, you'll see this functionality within the adaptation workbook online, and you can toggle these at will and watch that dot jump all over the vulnerability graph. It's kind of a fun thing to do. So you may have noticed that the forest types that we've been talking about are preloaded from our vulnerability assessments into the adaptation workbook. And I think several of you have already chosen some of these forest systems to help describe the place that you are working with. These forest ecosystems are drawn from our assessments, and each of the forest systems have, like Leslie pointed out, some sort of determination of potential impacts and adaptive capacity and even vulnerability. And I just want to take a minute to pause and say, if you don't ever read our vulnerability assessment, you can trust that 20 or more experts were brought into a room over several days to help make these determinations. And all that process is completely transparent, and all of those notes are included in the vulnerability assessment. So that being said, we're giving you the forest ecosystems for your location and giving you an idea of how regionally, at a landscape view, that forest system might be susceptible to climate changes. That's at a landscape view. So although, you may have central hardwoods and it may be considered low vulnerability, for your site, you might differ in opinion. And the adaptation workbook allows you to move those scales. So then you can decide, you can say, hey, well, central hardwoods might be low vulnerable across the landscape, but in my location, it is highly vulnerable. And so just to let you know, we have preloaded the adaptation workbook, but you still have the ability to make your own decisions using your expertise and judgment. And this is just going into a little bit more detail of some of the information that you can find within these vulnerability assessments that help to describe how we came to that determination. What were those major climate impacts? Were they positive for this forest type? Were they going to have a negative effect on that forest type? And again, with adaptive capacity. So if you see some of this information and you're saying, moderate, positive, what in the world does that mean? You can jump into the assessment and really dig into, those major drivers and stressors that might affect the vulnerability of this species. Okay, I'm going to skip questions and save that for the discussion and get right to the assignment. All of the, just to recap really quickly, all of the resources that we have talked about in this presentation are either linked to in your Getting Started guide, or they are linked within the adaptation workbook. And if you don't see them there, just send us an email and we'll make sure you get what you need. So your assignment for this time is to look at those climate change impacts and vulnerability resources that are available for your state and your project area. Once you dropped your pin, you should have something preloaded. If you don't, let us know. For places that are in a coastal area, sometimes if you drop your pin too close to water, it doesn't actually grab those impact statements, and so we'll have to help you move it back to the land. But for almost all of you, you should have something waiting for you in step 2. Again, take a minute to just watch some video presentations on climate change effects on forests, or open up those vulnerability assessments. They're about 200 pages long. Get started. But finally, at the end of this week, we'd like you to complete step 2. I've noticed a lot of people have already completed step 2. And for those of you, just continue to think about climate change and maybe go back and reassess how you have filled out step 2. For the rest of us, we can just get started. All right, so we'll have you do this by next Monday. And in our next class, which will be February 4th, the lecture will be much shorter, and it will introduce step 3, which focuses on how climate change might affect our management and our goals and our objectives. And then in discussion, we'll ask you to just recap your greatest climate impact. What are those big impacts and vulnerabilities that your site might be feeling into the future? And with that, I'll thank you and see you in discussion. Thanks for being here today, guys. Talk to you next week.